this video, we will study pulse position modulation and demodulation. So let us understand what is pulse position modulation. In pulse position modulation, the amplitude and width of the pulses are kept constant while the position of each pulse in relation to the position of a recurrent reference pulse is varied by each instantaneous sampled value of the modulating voltage. This means that the transmitter must send synchronizing pulses to operate timing circuits in the receiver. Pulse position modulation has the advantage of requiring constant transmitter power output, but the disadvantage of depending on transmitter-receiver synchronization. Generation and demodulation of PPM can be understood with the help of these waveforms. Here we have original master signal, a sinusoidal signal, a PWM waveform, its differentiated version, and positive half clipped. In this way we obtain pulse position modulation. So the generation of PPM can be obtained by using a differentiator circuit, a diode clipper, or rectifier circuit. Demodulation of PPM signal can be obtained by using flip-flop or bistable multivibrator, which has input as PPM signal and trigger pulses obtained from local oscillator. The output of this bistable multivibrator, that is PWM signal, is fed to an integrating circuit, and in this way we can have our original master signal at the output of the PPM demodulator. These are the various pulses. This is our master signal, carrier signal, pulse position modulated waveform, and this is a demodulated waveform, which is very much similar to the original master signal. In another representation, we have master signal, carrier signal, and pulse position modulated wave, like this. Pulse position modulation and demodulation on the kit. Let us identify various blocks of the kit. This block contains pulse position modulation system. The input may be taken from the signal generator. The signal type can be sine, square, triangular, or any arbitrary signal. The frequency can be selected from 500 Hz to 3 kHz. In between, any value can be chosen. Input waveform is measured at the input port of pulse position modulation, which is shown on the display of digital storage oscilloscope, and the output is taken at the output port of the pulse position modulator, which is shown at the display of DSO. This is our pulse position modulated waveform. This is our original message. So in this way we have performed pulse position modulation. Now the output waveform of pulse position modulator is fed to the input of pulse position demodulator, whose output can be observed at point number 23 of the pulse position demodulator, and in this way we have obtained the demodulated waveform as shown here. Here we can observe that the demodulated wave is an exact replica of original message. So in this way we have studied pulse position modulation and pulse position demodulation. Thank you very much.